My name is Drew, and this is my Lab 3 circuits presentation. This is the layout of the presentation. First, I'll introduce the concepts behind the lab, then discuss the experimental setup and key equations. After that, I'll go over our predictions, results, circuit behavior, the RC circuit concept, and finish with the main takeaways. Okay. In a series circuit, every component shares the same path, so the current remains constant throughout the circuit. The purpose of this experiment was to see how these conversation principles appear in practice by comparing theoretical calculations with simulated measurements. Okay. Go. Instead of building a physical circuit, we use a circuit simulator to model the electric system. This allows us to measure current and voltage at different locations while observing how the circuit behaves under ideal conditions. The equations shown here were used to predict the circuit's behavior before taking measurements. These relationships allow us to calculate current, resistance, voltage, so we could compare our predictions with the simulator. Okay. Using the total resistance and the applied voltage, we calculated expected current before running the simulation. These predictive values served as a reference when evaluating the accuracy of our simulated results. This portion of the lab demonstrates Kirchhoff's current rule. The measurements confirm that the same amount of current flowed through every part of the series circuit, supporting the principles of charge conservation. Okay. This experiment also highlights the difference between the two measuring devices. The ampere measures current and is placed in series, while the voltmeter measures potential difference across components without significantly affecting the current. Okay, this simulation shows how electric potential changes throughout a circuit. The batteries increase the potential energy of the charges, while each resistor causes a voltage drop. By the end of the loop, the total change in voltage returns to zero, which agrees with the Kirchhoff's loop rule. Although we explore the RC circuit through the simulation, it still demonstrates the basic behavior of a resistor and capacitor. The resistor controls how quickly the capacitor charges and discharges, producing the exponential behavior that characterizes RC circuits. This scenario considered what would happen if the resistor were removed from the RC circuit. Without the resistor, the capacitor would charge almost instantly, producing a very large initial current. In real currents, internal resistance prevents the current from becoming infinite. Okay, and the key takeaway: a resistor controls the charging rate and limits current, making RC circuits safe and predictable. Okay. Overall, this lab strengthens my understanding of circuits analysis by allowing me to compare theoretical calculations with simulated measurements. It also reinforces how Ohm's law, Kirchhoff's rule, can accurately predict the behavior of electric currents. In conclusion, the simulated measurement closely matched the theoretical predictions. The results confirmed both energy and charge conservation, demonstrating that Ohm's law and Kirchhoff's rule provide an accurate description of series circuit behavior. Thank you for listening.